Hello, welcome to the Black Hole. Our next presentation will be about platform-independent builders for graphic platform-independent builders for graphical user interfaces for microcontrollers, and yeah, the topic is adding hardware platforms for Envox EEZ Studio LVGL, and please enjoy.
Thank you. So I am Goran, but you already know that I'm here frequent guest. So today I will talk about the LVGL and EEZ Studio and how I added the platforms. But actually before that I need to talk about lots of things because it is all interconnected. So this is a little bit about me, but yeah, you already know everything. I am repair technician, but now I am co-founder and I'm working on the open hardware design and of software and hardware. I am long-time member of Radiona, and I'm there almost 10 years. We have lots of activity there, so make sure you visit us in Zagreb. We are at Nova Cesta. We have lots of artists, electronics and designers in space, and we have lots of workshops and lots of activity. We even have once a month, we try to keep up with this schedule, but once a month we have repair cafe. So there we have some experts and general public people that are arriving in the space, and expert is just showing people how to disassemble and fix some hardware. I'm a founder of Intergalactic. There I'm doing all the software and hardware design, helping other people to get better in development and in this open source area. I am often funded by NLNet, and they are really good partners. So if you can check their website if you need some funding for the open project. So they are I think for 3 years giving me some grants for the projects. ULX4M, my mobile FPGA board, is actually partially funded by them, and some new things like things that will be shown later. I will tell later about them. In this talk I will talk at the end of the talk what I did, but it all started with the EEZ benchbox. So that's like modular measuring equipment, and among other things it is a power supply. It can also be function generator, and it has it is really feature rich, so it has, like, you can communicate with it, you can set the automatization, you can use it over the Skippy commands. And while Envox was okay, I will talk about this later, but there is like enormous amount of feature in this hardware, and it is also a Croatian product. So at one point Envox contacted me, and we started collaboration in one project to combine FPGA board with this modular power supply. So we wanted to get like oscilloscope or digital analyzer for signals, so it would need to combine fast signals with slow signals, so we did some things with it. And we got to some places, so I have designed a board that has combined STM and FPGA, and we got some results like over putting picture on the picture like FPGA on top of the GUI that was designed for the benchbox 3. At that time, Envox had a GUI builder, so when they started to actually working on the power supply, they needed something, like it would be too hard to do everything in code. So when you have like graphic, you need some graphical designer like Qt or something, and you want it to have it like easier way to do GUIs and not to do everything manually. So they have designed actually the studio as a studio for building the GUI interface for the benchbox 3. but it is also used for other purposes, like controlling and automatization of the measuring equipment. Here are some screenshots from the studio builder. So you can, like, it is like just drag and drop thing. So new versions has lots of other features. Among other, there is LVGL support that is more hardware independent, but I will show it later. Here you can add like graphs and everything, and like have all the graphics in this project. And in previous version, all the code that is like platform specific, like toggling buttons to getting signals out in, was done actually in the code. Latest version of the EEZ Studio now has the flow part, and the flow part is like low code programming, so it is visual programming. So you can have like boxes, and you can have you can design it visually, so you can do low code stuff, like almost you don't need to go into your build environment for your board and do it there, but there are always things that you need to, like connecting to Wi-Fi or something you need to do in the code of specific target. Recently they also have a visual debugger, so you can have it like, here is visible like how you can set the programming. So you have like all visually in the flow, and you can set the breakpoints, you can check the variables, like in the normal, same like in the normal debugger, it is just visually shown. You can see the signals are moving. When you have the signals that is, or variable that is sent from one place to another, you will see the arrow that is like the line that is lightening in the area of where the variable goes. And at some point I needed to automatize tests for the ULX3 batches. And at that point, Dobrica, you probably all know Dobrica, he did some batch scripting for this testing. But when I was talking with the production company, they actually want to see it on the like screen. So they don't want to use like many scripts to test everything. So they want like on the screen to present what is happening and what they need to do. So Envox helped me with creating complete flow for the ULX3S batch testing. And on this flow, so the user can see each board that is plugged in and in which state is that board. So if something is needed like button pressing or check the screen, it is written. So please check the screen, and then user needs to click, yes, I see something on the picture. If it's like press the button, you need to press the button, and are all LEDs on or something. Yeah, but the problem on the old studio was that it was not platform dependent, but it was like done on the STM before it was done on something with Arduino. But lots of things needed to add the platform. It was like hard because you needed to add hardware graphical library and all those libraries and mix, and it was like hard to add new platform. So Envox searched for the best solution, and they found that LVGL, that is fully open source graphical library, it is completely hardware independent, so it can run on almost anything. So LVGL can even run in UEFI BIOS or like in simple things, so it is really fast, and it actually takes care of the complete graphical environment. You just give it like some functions, like when it needs, like put the pixel on the screen or to switch frame buffers. You can have 2 frame buffers and just switch the pointers between them. Or you can give it like just put pixel function to your platform, and that's it. So that's everything else will be done by LVGL. But LVGL is like, you need to write it. There is a Squareline Studio, and that's from the author of the LVGL. and it is cool studio. It is also a visual drag and drop user interface. It can create beautiful graphic user interfaces, and it's also platform independent, but it doesn't even care about your platform. So you will get folder that is GUI, and now you need to connect that folder with your code. But it cannot generate functions like change screen. So you will have the button, and you will need to add implementation of changing off screen. So go to screen, you will need to write that by coding. It is also not open source, and it is cheap, but it is not free. So Envox added many things, among others. I think that most of all of those features are co-founded by NLNet Foundation. So when I noticed that they actually added LVGA integration, I already used EEZ Studio, so I know that it was really capable thing, but I didn't know, like, I know that it was hard to port other hardware on it. So when I saw that they are on M12, that they added LVGL integration, I started to ask them how can we maybe add some other platform that will be more more closer to the users, because STM was like, there was no STM on the market, so I think just two actually MCUs were like largely available, like ESP32 and RP Raspberry Pi 2040. So yeah, we actually started to do something with it. So this is the newest LVGL GUI builder. Now this is just a part of the studio, not the part where you can control the measuring equipment and have a log and different things, but you can do it from here. But this is like GUI builder that has support of the flow, and this is the latest version that is on the picture is shown how it looks in the studio. So you can see this like change picture. You have just just one label that you draw a line to it. So when something is pressed, then it's like picture will be changed. So you don't need to write that part in the code. And you see how how it looks on the hardware. Okay, so after I searched for how can I like add more to platform, it was intuitive. So it was Studio is generating also just one folder, and you just need to include that folder into the build, and you have two functions. One is for LVGL update, and one function is for the EEZ flow update. So you have just two functions that you need to call in your environment. So I started to search what is easy way to do it on, like, for example, ESP32, and I have found some already ported thing. So there was already available LVGL running on the ESP32, but the version was like 8. I think that 7. Official version for ESP32 on LVGL is 7.9. So some updates was needed. So I have found 8.2 and work up on that, and got something that was running. So, and with big help from Martin, he's working for Envox, and lots of CMake, sdconfig and makefile changes, we get to the first compiled version of the LVGL and EEZ framework. So I was now able to create my own, my own GUI stuff. So for my first project, I started with so I have the bench box at my working desk, but this is really apart from me. So I'm soldering things on the table, and I can always turn up my PC and send commands to control it, but it was always hard to start up PC, wait for it. So I just need to power up something, turn it off, and like ultra simple things. So that was my first actually project that I did with the Envox GUI, and yeah, usually it is possible to connect BB3 on the pedal, so you can use simple things like you can set that pedal will be power off, power on channel. But yeah, I needed a little more complex stuff. So I started as I had ESP32 that is already Wi-Fi, has Wi-Fi on it. So I have started with the Wi-Fi Bluetooth 3 touch controller. And this is what I did. So this is based only on, there is no pictures are not used. So I'm not using bitmaps or something, just the design. So this is like just pure, like CSV. So it's just like the design things. So it's not maybe a perfect thing, but it doesn't have the bitmaps. And like I'm using just the simple things like change channel, set up Wi-Fi and things. So, and once I got like design ready, I just build it for the ESP32. So first version, if you see in the background, first version of ESP32 was like soldered with the wires. So I didn't have like some fancy board like with the ESP32 and screen. So I just built one by myself and added this GUI builder. And it was like solidly fast. So it was like you can see this when it's nothing is happening, it's like 50 frames per second and using just a little bit of CPU. But LVGL actually it is like that. So if it's when you have like small changes on the screen, it will just change the part of the screen. So if you change just one pixel, it will not change the whole screen. It will just change that pixel. So that's how, and that will hold in the frame buffer. You can give it like only one line of buffer or the complete buffer, or you can use two buffers and switch. So it has lots of different options. And LVGL, it's like you can do many things with it. It's not strictly defined, so you can override some functions and you can have some callbacks that are like empty functions that will be called when something is happening. It was fully simple to actually add this as a project, as a new project. As I had support for ESP32, and I have soldered now a radionica screens. I just added little bit more, so I just needed library to write on the screen. So now I can do demo actually in the Envox GUI and show it on the screen. So I can set like, show me this picture, wait for like 5 seconds, then show me this picture or whatever I need. Get the data, push data, so I can do most of the things from the GUI. Okay, and when I started to do some like maybe slower things, like most slowish thing is like if you want to rotate a bitmap or some graphic, that will take, because it needs to rotate and always drive through the screen. So I have noticed that it is a bit slower when I'm using the ESP-def because something is not set right, and it is not, after some search I have found that it is not using the DMA for controlling the screen. But I have found that the Platformio has some options to enabled, and it can actually enable the DMA transfer. So I have ordered those M5 stacks. They are a really popular platform for everything. So I just bought one and I set it up. It was also easy. So I just added 2 folders and used LVGL and Flow as a library, and it completely compiles and everything started to work. So this is and this is how it looks. So it's like, here is maybe, yeah, it's not super visible, so, but you will see. So when actually this start, when you put this start point, that means that it's on screen opening. So when the screen is open, then do some delay and then do some things. Now on the right side you have like many options, many widgets, many functions that you can, and it's like you can easily add your own maybe even platform dependent that floating function, yeah, visual function. After ESP32 and the many things that I tried with ESP and the screens, I checked for the RP2040, as that was second that was actually available, more available chip. And actually it is also using Platformio, so I just added few things and I got it working. I had some problems with, I think, touch or something. So I needed to work and debug, and it was really cool because Platformio, I think, actually later I switched to VS Code. It is supporting, like with the second Pico, you can build one Pico that is, debugger. So you can use one Pico for the debugger and debug the second one. So I have used the Pico debugger in VS Code to find the bug in this code and got the LVGL running also on this platform. And after that I just picked the random boards from that I have and imported everything I had on the, yeah, so. And actually latest work that I did was yesterday. So you saw the F4 board that is having the latest sample from Envox. So I have just taken the GUI part of that board, added some little things, and before that I was checking what is the best way to run something fast on the Raspberry. So on the Raspberry you usually need to wait a lot to boot a Linux, and then the problem is like it is overusing the SD card, and you will need to wait, and most of the time if you use it for something that will work for a longer time, SD card will probably break and you will have like you will need to go to the field to fix it. So recent versions of Raspberry, like CM4 modules, they have the EMC blocks, so you can it's like flash memory, so you can like use it instead of the SD card. But yeah, and to get it faster, I have found the Circle. So Circle for the Raspberry Pi, that's like bare metal programming environment, and it's really super fast. So you need, at first I needed, I think, 10 seconds, and that was like for the Raspberry Pi start. And slowly I have asked the author and he told me what to remove, whatever. And after some time I got to the 5 seconds, and then I searched for the code, and I had like on the start I had 5 seconds blink LED, so just to notify users that it is starting. So after I have removed this starting 5 seconds, it actually started to boot in like seconds or 2, so it was like ultra fast. And actually that is almost everything. So I just wanted to check like this live demo and show you like this boot, how this Raspberry boots. Okay, so we have the HDMI, and most of the time is actually on the HDMI monitor or presenter to find the signal. So it's not the Pi. Pi is probably booted already, but we will see. So this is it. And this is actually, I just copy-pasted the STM F4 design on the Pi. I needed to fix some things like the screen size and different things, so I set the screen size of the Raspberry to like closest one. But this is just like almost no work from platform to platform. So that's like, it has many benefits because you can switch platforms like. So Circle also supports mouse, so I have mouse. I added like DORS CLUC here, so we have, and it's really fast. So you can see this demo was done by Envox, so it is by Martin. So it's really fast, and this is and this demo combines like bitmaps and designs for the buttons. I have here like main HAL, so I can set here security. I have lock, unlock, and lighting, and actually you can see that it's like very fast demo. It's same like on F4. It is running really fast. I think that Circle doesn't have some hardware acceleration. On STM you can use hardware acceleration. There are also like on some other platforms you can use on the Linux. You can also run this on like any Linux because you can just compile it. You can also run this in the simulators. Maybe I can even, I don't know how much time I have, probably some more, 5. Maybe I can switch back and show you like that. Okay, I will just get back to the slide. I think that okay. Okay, so we have the web simulator. We can start the simulator, and the complete BB3 will be actually loaded. So we have down we have like Skippy commands. I can send Skippy commands. So the complete GUI is the same as on the machine. So you can do like testing and everything, and do more development on the actually in the and see in the browser how it is working. So you can see this is okay, the same thing. So we have it. That will be the same you will have in the hardware. So it's the same firmware. Okay, no. So I can no, I don't want to calibrate. No. So we can set like some voltage, but lower probably because so we have a voltage. We have milliamps. We can set some here is like function generator, so we have it here. Select channels. Okay, select. Okay. So here is like some simple function generator. Okay, and like in settings we can see that there is lots of support. So you can even change the module, but then I will need to reload the page. So everything you do in the studio you can build for the Linux or for the web environment, or you can even build the web pages with it. So it's really like complex and most important, it is open source and free solution. And actually that's it. So you have links here, so if you need to contact me, that's it. So thank you. If we have time for the questions, maybe. Are there any? No? But I am in the hall, and there is lots of things there, and most of the things are from Radiona. So we have Igor here, Radiona member. He has Letva. It is quite popular among students, and there are lots of consoles, and so you can play and do stuff. So thanks again.